All right, Cowboy Joe back here. We are going to finish our discussion on this with two problems, one on each of the tougher equations that we learned. And this one is asking what is the final temperature of the mixture that tells us we want that big fraction. So, again, on this big fraction, we are trying to focus on two different items, and they're sort of separated right there at the pluses. So on the left side of the plus in this big fraction, we want to focus on one item. And let's say we got a sample of water. I'm going to actually click forward to make sure I don't screw you up. Let's go water. Let's go water is blue. So let's go back to our blue. So water is blue. Everything about water. We got an initial temperature of water. We got the initial grams of water. And we have water specific heat in the table. So now let's identify in red, what are we mixing with water? Is mixed with water. We're putting water and water in this one. Same amount of water as well. This looks interesting. So we have water at 80. We're mixing with water at 10. So this is also our C for the red side. So this is red water, and this is blue water. Red water looks hot. All right, so 200 grams. It's just a fancy way of writing 200. So we got 200 grams there, 0.2 kilograms times 4180. The initial temperature would be 80. And again, the 0.2 and the 4180 carry down. M and a C, M and a C. And now let's talk about the red water. Again, we have 200, which is 0.2, 4180. And the beginning temperature of the red water is 10. Now, why can't we just cross-cancel everything? Well, remember, you can only cross-cancel factors of the numerator and denominator. This 0.20 is a factor of this expression. It is not a factor of the entire numerator. But if we factored it out of both of these terms, then we could cross-cancel it. But to be safer, you may not want to cross-cancel if you don't completely understand when to cross cancel. So again, multiply these three to get that number, multiply these three to get that number, multiply these two to get that number, multiply. So multiply each expression, and that'll reduce it to four numbers. Then add and subtract the top and the bottom, and then divide finally. And we get 45 degrees. And that should make sense. If we have hot water and cold water coming together, well, what's it going to do? It's going to meet at the middle. So lead fishing weight, oh boy, I got to get rid of some things. We got lead fishing weight. What's going on with the lead fishing weight? We're placing it into water. So let's click up some answers here first. This one says, what is the specific heat of the lead? So we're going to look for the longer one. Now, we're not just referencing it off a chart. Lead fishing weights is an alloy of lead and other metals. So we're really looking for what is the specific heat of the fishing weights, which are mostly lead. So it's not going to be that 130 number that's on the chart. So anyhow, let's look up on the left. We have the 0.3 number. That's this one. So we're going to go with, just to keep everybody in the same game, this side is going to be the red dots. So we have 300.3 kilograms lead fishing weights with a mass of that, and at this temperature, lead fishing weights. That's all we know. We don't know the C. The C is unknown. So now let's go to blue. Are placed in 100 grams or 0.1 grams of water at 35 degrees. This is water, so the C is the specific heat. So this is the water side. And the number that is shared for both sides is that TF. Let's go with green. TF. This is the final temperature right here. Final temperature is 45. That goes in for TF and TF right there. All right, so get your numbers into the equation correctly. So we have 300 times unknown. Final temperature is 45 minus beginning temperature of the lead, which is red. Beginning temperature of the, oh, it's 100 degrees. So get your data in there correctly. That's going to be the hardest thing. And then for the water, we got 100, which is a 0.1, times the specific heat, which is 4180, times the final again, which is 45 minus the beginning temperature. And again, one of these two binomials are going to be negative. And it's this one right here, 45 minus 100 is negative 55. So that negative would float out in front of the term. You got negative this times 55. And if we add it to both sides, it flops over to the right as positive. So now we can go straight to our calculator, and we take this times this times this divided by this divided by this, and we get our answer, 253. I got one more problem we're going to talk about. Nope, that's it, actually. That concludes our lesson.